Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you design of symbol code generator. How to design a symbol code generator. You know what is code generator, right? Code generator means it is the last phases of compiler, that is from the 3 address code or intermediate code, we are going to generate a code generator. So the previous phase is code optimization, that is also 3 address code. Okay, so the target code is generated from the sequence of 3 address statement. Okay, so I told you know in the first phases of compiler, that is we have the last phase is code generation, and the previous phase is code optimization, and the previous phase is intermediate code, that is 3 address code. So code optimization is also 3 address code. So code simple code generation algorithm or simple code generation design is to produce a target code from the 3 address code. Okay, I hope you understand, right? And it uses 2 descriptors. Okay, why we are uses 2 descriptor is in order to keep track of register and address. Okay, register and address for the names. So register is memory, and address is a pointer. Okay, so register and address of the for the names. So what is the there is a 2 descriptors, one is register descriptor and another one is address descriptors. So what is the register descriptor is it keep tracks of what is in currently present in the register. Okay, so register descriptor uses it keep tracks of this is register register 1 for example. So it keep tracks of what is present inside this register. Okay, and also it is consulted with new register is needed. For example, in the procedure or in a program, there is needed for another one register, it consulted with the whether we needed it to register. Okay, so that is the use of register descriptors. And what is the use of address descriptor is it keep tracks of location. Okay, so there is a 2 descriptor, register and address. Register it keep tracks of what is present currently inside a register, and address is it keep tracks of location. Location may be register or stack or memory address. Okay, this is the location, maybe it is a register or stack, or it is a memory location, heap memory or some other memory locations. Okay, and it has 2 address, that means in address descriptor it uses 2 address, that is opcode, this op is for opcode, and source and descriptors. Okay, source and destination, source and destination. So op it stands for opcode, and source and destination stands for fields, data fields. Okay, so for example, move add and subtract. So if you take move, it is opcode, that means the register is moved from source to destination, or the value is moved from source register to destination register. And add means it add from source to destination register. So subtract, it subtract source register with the destination register. Okay, so that is the opcode. And source and destination are it's combining register and a memory with a location. Okay, that is the use of source and destination field, data fields. Okay, and then the next topic is how to find the instruction cost. There is a formula to find the instruction cost: 1 plus cost associated with the source and destination address. Okay, so 1 plus cost associated with the source and destination address mode. Okay, if you take the register have cost is 0, if you have a register that cost is 0 within a memory location, if the register have a memory location, then the cost is 1. Okay, so how to find the instruction cost? 1 is a common term and is associated with source and destination mode, address mode. Okay, for example, move b comma r0, move b comma r0. So move is a register, move r0 is a register, move is an opcode. So so the commonly if it is have a 1 plus cost of address, if you have a register the cost is 0, but we have address mode, that is 1 is common and associated with the source and destination address, the register addressing mode is 0, cost is 0, but B the cost is 1. Okay, so the for this instruction the cost is 2. Similarly, add is an opcode, R0 register the cost is 0, but B the cost is 1, but 1 is the common term and 1, that is 2. And similarly this also 1 plus 1. Okay, so move is an opcode, register, for register the cost is 0 and A cost is 1, so 1 plus 1 2. The total cost of this instruction is 6. Okay, this is the way to find the instruction cost. Okay, so this is the overall introduction about design of simple code generator, and there is a simple code generator algorithm. Next is simple code generator algorithm. So you know the input is a basic block, that means 3 address code basic block. Do you know what is basic block? Let us take one example, x equal to y opcode z, that means y operator z or y op z. Okay, so it may be a plus operator, then y and z is added and is placed in a x. Okay, how the simple code generator algorithm is designed is, first it invoke a function get register of, GET one function is there. Okay, so by using this get register function we can find the L means it is a location. Okay, where will be the register or memory location. Okay, so using this get reg function, first we should find the L, that is location, memory location. Then consult the address descriptor. Here I told you know what is an address descriptor. Consult with the address descriptor for y to determine y. Okay, if that y is not in the L, then generate move y in L. Okay, can you understand? That is, consult the address descriptor where L is present in where y is present in L. If y is not present in L, what we want to do is we will generate the move address, that is y in L. Okay, we are going to generate, that means we are going to place y in location L. What we are find a location using get register. Clear? And then it generate instruction operate z dash. Okay, that is L where z dash is current location of z. Okay, so z dash we are assuming, so that is L location where z dash is in the current location of z. Okay, then if it is true, then update the address descriptor with x, indicate x is in a location, x is in a location L. Okay, so first one is using get register we have to find location, and then consult with the address descriptor we will move y with L and then generate instruction. And final one is, if the current value of y and z have no next use, that is there is no next use of instruction, then exit from the block and is in a registers. Okay, so this is the code generation algorithm, right? So the design of simple code generator, you should know what is the design of simple code generator: 2 descriptors, address descriptor and register descriptor, and then instruction cost, and then design of simple code generator. Okay, thank you.